Reducing 2 square root of 32, and we're reducing a half square root of 250. What did y'all break 32 by? 16 and 2. All right, so square root of 16, square root of 2. And which one was your perfect square? The 16. 16 became 4, square root of 2. And then what do we have to make sure not to forget?
Times.
The times, right? What are we multiplying by? The 2, right? That 2 in the front needs to be brought down. 2 times 4 is 8. Our final answer should be 8 square root of 2. All right, what about the 250? What did y'all break 250 by? What two numbers?
$25 and $10.
25 and 10? All right, so 25 and 10. And taking those with the square root, which one becomes, well, which one is your perfect square? 25 becomes 5 square root of 10. And then we multiply that by a half. So if I don't want any decimals, what would that fraction be in front? 5 over 2, and then square root of 10. So I know that last answer looks, I would say looks ugly, right? It's not a solid number, it's not a decimal, it's just an alpha fraction. You're gonna see a lot of those today. You're gonna see a lot of fractions that maybe don't look, you may think I did something wrong, but a lot of your answers may look like that. All right, so it's gonna go over to the notes. We're gonna go ahead and look at multiplying and dividing. So like yesterday, the steps for multiplying are in the box. I'll go through them, and then I'll go through them again as we're going through the problems. So the first step says, multiply the whole numbers together, then multiply the square roots together. So multiply the whole numbers together, and then the square root. So what are my whole numbers on example 1A? What are the whole numbers on example 1A? 2 and 3. So you're going to do 2 times 3. 2 times 3 is 6. Then it says, now multiply the square roots together. What is square root of 3 times square root of 3? What's 3 times 3? Square root of 9. It says, find the highest number in the list of perfect squares, then divide it into the radical being reduced. So normally what we would do is try to figure out how to break down the 9. But 9 is a perfect square. So what's the square root of 9 then? Just 3. So this just becomes 6 times 3, which then becomes 18 as your final answer. So multiply the whole numbers, and then we multiply the square roots. So let's do the same thing with B. What are the whole numbers? 5 and 2. 5 times 2 is 10. All right, now let's do the square roots. What's 2 times 3? 6. Can we break down the 6? No, right? So can I do anything else at this point? No, so you're done. So sometimes it's 1 step, sometimes it's 3 steps. It could be 6 steps. It just depends on the problem. All right, this one has no whole numbers in front, but we do have 7 and 13. Can someone multiply 7 and 13 for me? What do we get for that? What is it? 91. All right, do y'all think any of our numbers will go into 91? So half of that would be about in the 40s. So maybe let's start with 49. Will 49 go into 91? No. After 7, it's before 7 is 6. Will 36 go into 91? No. 25? No. 16? No. 9, thank you. 9, no. And then 4. No, right? So then we're done. Nothing can go into that one. All right, so go ahead and try the same thing here. Again, the last step in our little box just says before you decide you're done, just like yesterday, always make sure that the number underneath the square root cannot be reduced. So go ahead and just try these 3, please.
6 and square root of 25.
Good, 6 and the square root of 25. And then what did you do after that?
6 times 5.
6 times 5 gave you 30. Awesome. All right, Noah, what did you do for the next one?
6 times square root of 12.
6 times the square root of 12. And then?
Got square root of 4 and 3.
Square root of 4 and 3.
And we just did 6 times 2.
So then that becomes 2. And 6 times 2 gave you?
12.
So 12 square root of 3. Awesome. And then Alexi, do you mind doing that last one? You didn't do it? It's okay. Zane, do you mind doing that last one, Zane?
Get 10 square root of 36.
Awesome.
36 square root of 6, so multiply 10 plus 6,
60. Awesome. Thank you. I do want to come back to B. So if you notice on the next thing, the item at the bottom, it says sometimes reducing the radicals at first can be beneficial. So this is a set step, right? Do the whole numbers, do the radicals, simplify. Good if you need something that concrete. But some of you may think, okay, well, could I have reduced what first? What's reducible here already? The 4. So you could have reduced that 4 to a 2, multiply that by 3. All of that times 2 square root of 3. Well, what's 2 times 3? 6 times 2? Your answer would have been 12 square root of 3. So if you want to reduce from the beginning, feel free to. If you want to do the multiplying first and then the reducing, you're going to come out with the same thing, as long as you reduce or simplify using the correct steps. All right, so the last thing we're doing is dividing. So once you're done copying this, if you want to flip over to the back side. So on the back side, we have a different set of steps. Sometimes this is what I would recommend. So I would recommend separating the numerator and denominator into separate square roots. So for example, that first one, I'm going to separate it into the square root of 3 over the square root of 49. Then it says reduce any perfect squares. So what's my perfect square on this one? 49. 49 becomes 7. And here we have the square root of 3. It says for the numerator, find the highest number. Well, nothing goes into it, right? It's already reduced. And then number 5, it says before you decide you're done, make sure the number underneath the square root can no longer be reduced. That's something we did on the front side, something we did yesterday. The other thing though is there are no square roots in the denominator. For it to be officially simplified correctly, you cannot have a square root at the bottom. Do we have a square root in the denominator? No, so you're done with this one. Again, some problems are 1 step, some of them are like 10 on this one. It just depends. It depends on your process as well. All right, so what's our first step? What are we going to do when we're dividing? We're going to separate them. Yep, just separate them. All right, we're going to reduce any perfect squares. Which one's your perfect square? 25 becomes 5, and then the square root of 3. So this is one where on that 5th step, it says, oh, I have a square root in the denominator. If this happens, you're going to multiply it by a value of 1. Now, not 1 as in the number 1, but a value of 1. So to do this, to get the square root of 3 to just be 3, I have to do what to it? What do you think would convert that to just the number 3? We saw it yesterday. Multiply by itself, right? So squaring it. Remember yesterday when we saw this? When we were doing Pythagorean theorem? Do you remember? Aiden? No, you don't remember seeing that as a side on the right triangle? Okay. And then what was happening? What would happen when you would square a number that's square rooted? It just becomes 3. Okay, so that's the idea here. If we square it or multiply it to itself, we'll get that whole number at the bottom, which is what we want. The only thing is, though, if you multiply it by itself and you do it to the bottom, you also have to do it to the top. And if you think about it, square root of 3 divided by square root of 3 is just the value of 1. It's just the value of 1. It would convert to a 1. So this step is going to be repetitive anytime you have that square root at the bottom. You only multiply by that square root. So the top, can I multiply, thinking about what we did on the front side, can I multiply 5 and the square root of 3? Like, can I combine them? Were we multiplying square roots and whole numbers on the front side? No. So all you're going to do here is you're just going to rewrite it. This is going to be 5 square root of 3. Now, this next step I'm going to show you, but I guess you can consider it a shortcut. All right, what's 3 times 3? 9. And then what's the square root of 9? 3. So this just becomes 5 square root of 3 over 3. A lot of your answers will look like this when it comes to dividing. Not all of them, but a lot. Now, the shortcut is here. you know you're multiplying it to itself to eliminate the square root. So y'all really don't need to show this step. If you know what's happening here, y'all can just go straight to converting it to that whole number. Because that was the whole point of us multiplying it to itself, to convert it to the whole number. All right, so let me have you guys try the next 4. Let's just see how we do on those next 4. And then that's it for today's notes, okay? And then we can finish up the homework. On that first one, Leon, what did you do on that first one, Leon? What's the first step say? Okay, so what were your 2 separate square roots?
Square root of 5 and square root of 16.
Good, and then what did you do after that?
I did square root of 16, so 4.
Mm-hmm. And what was the top?
It stayed as square root of 5.
It stayed as square root of 5, correct. Thanks, Leon. Will you do the next one?
The square root of 49 over square root of 81
Mm-hmm.
just simplifies to 7 over 9.
Just simplifies to 7 over 9, correct. All right, next one. Aiden, what do you got on the next one?
Okay, so it's 36. Separate one with square root of 36 and square root of 5.
Mm-hmm.
The 5 stays the square root of the 36 goes to the normal 6. And you have to multiply both by the square root of 5. And then I got 6 square root of 5 over.
Perfect. All right, and then anybody want to do the last one? Does it stay the same? Do y'all think I should just leave it as is? When I separate it, this is what I get. No? What's wrong with it? What do I need to fix?
Square root of
The square root at the bottom. So how do I get rid of that square root at the bottom? Multiply it by itself. The bottom becomes
25
square root of 25. We can also go straight to 5 if we want, right? And then the top, can I multiply 7 and 5? Yes. What's 7 times 5? 35. All right. Now, the only thing I want to point out is, suppose, and you can just add a little bubble there just to indicate that that has nothing to do with the ones we did. If y'all want to call it letter E, I guess, you can call it letter E. But let's suppose I have, let's say I multiplied, and I came out with 2 square root of 32 over 4. Multiplied, this was my answer. And you're like, all right, there's no square roots at the bottom. But what can we still do? You always have to make sure what? Simplify. Will anything go into the 32? The 4 and the 4 and 8. Ooh, if it's 4 and 8, think about those numbers. Good discussion. If you think about 4 and 8, is 8 going to still be reduced? Yeah, so that means there's a bigger number than 4. What number bigger than 4 will go into 32? 16. All right, and if we didn't see it, it would be fine.
No, we on the same.
The only thing is you would just have to continue reducing. So 16 and 2. And then the bottom is 4, right? So what's the square root of 16? 4. Square root of 2 all over 4, which then becomes 8 square root of 2 over 4. All right, nothing goes into 2. No square root at the bottom. Does anyone see something you can still do, though? Reduce the 8 and the 4. 8 and the 4, these are whole numbers. It's like looking at this and seeing it in the format of 8 over 4, square root of 2. Do you see how this fraction can still be reduced?
So it would be 2 square root of 2.
So reduce any whole numbers if possible in front. Your final answer would be 2 square root of 2. All right, good discussion.